So now this is a kind of question that you guys will see a lot in the exams. Okay, you get this in the papers from grade 10. Actually, it starts with similar kind of questions. But grade 11, grade 12, you're going to see this kind of question a lot. A parabola and a straight line. Okay? And there's certain questions they always like to ask when it comes to these kind of questions. Okay, so we're going to look at different ways I can ask it. But let's start with the first one here. They gave you the parabola x squared minus 2x minus 3. Okay, g. Okay, and then I gave you the straight line mx plus c. So obviously we're going to need to find m and c, the gradient and the y-intercept. Okay, but now the first question was determine OC, that distance there, and AB, that distance over there. So obviously, let's start with let's start with OC, okay, because it's easy to find C, the coordinate of the y-intercept, okay, of the parabola and the straight line, which is right there, -3. Okay, so it's given that the y-intercept is -3, so you can just put it in here, okay, -3, it's your y-intercept, the parabola, and then from 0 to -3, we can say OC, the distance from always the higher one first, and then minus the lower one. Always the higher one minus the lower one. Okay, and because it's a vertical distance, you don't have to use the distance formula. You only use the distance formula if it's a line with an angle. Okay, with a gradient like this line. But if it's going straight down or horizontal, you don't need the distance formula. You always just take the higher value minus the lower value. And then you get 3 units, okay? So there's the distance of OC, it's 3 units. And then for AB, we're going to need the x-intercepts. Okay, so now we go to this equation, x squared minus 2x minus 3, and we put it equal to 0, and then we just solve it. Okay, and we get 3 or -1. So put the equation to 0, solve for x, and you cut your x-intercepts. So we can say therefore AB will be the bigger one minus the smaller one. Always the bigger minus the smaller when you want the distance. Okay, vertical or horizontal distance. Okay, so it's going to be 4 units. So then we found OC and AB. That's the start to this question, finding those two distances. Okay, so the next one is finding the turning point D. Okay, the turning point, there's 2 options to find the turning point. Okay, you can either add the 2 x values, divide it by 2 that you find in the middle, and you get the x value, and then you put that x value into the equation, and you find the y value. Okay, the other option is to use the x equal to -b over 2a. You can use this method, x is equal to -b over 2a. And then you substitute. -b would be -2 over 2 times a, which is 1. And then that gives you 1. So then you know it's going to be at 1, the turning point. So then the x value will be 1. Okay. Right, so like I said, the one option is -b over 2a, which gives you 1. Then you put 1 into the equation, g1. And you substitute 1. g1 is 1 squared minus 2 times 1 minus 3 is -4. So the y value is -4. And you got your turning point, d1 and -4. There's the turning point. So 1 is your x value, -4 is your y value. Like I said, the other option is add the 2 x values. -1 plus 3 is 2, and then divide by 2, which also gives you 1. So there's 2 ways to find the turning point. Okay? When you have the sketch, you can find the x-intercepts, or you can use the -b over 2a when you have the equation. And then you get the turning point D. So now the next question is to find M and C for the straight line. We want to find the gradient and the y-intercept. So we know the straight line goes through a -3. So we know the y-intercept is c equal to -3. Okay? So all we need is m, the gradient. So what you can do to find the gradient is you can use this coordinate here and you can use this coordinate here. So this one is 3 and 0. This one is 0 and negative 3. Okay? So you substitute them. If you want to make sure you don't make a mistake, you can first write them down. Just make sure 3 and 0, 0 and negative 3. Make sure you substitute them correctly. Negative 3 minus 0 over 0 minus 3. And you're going to get a gradient of 1. So we got C and N. So that means fx is going to be 1x minus 3. So it's just x minus 3. Okay, x minus 3. Right, so the next question is, after we found the equation of the straight line x minus 3, now we need to find out where is gx smaller or equal to fx. So gx, the parabola, smaller or equal to fx, the straight line. So it must be smaller, so this one must be below this one. That's what it means, below. So that means we want to know this part here, okay, from there to there. That's where it's below the straight line. The parabola, below the straight line. So it's from there up to there. And they always want you to write it in terms of x. So you're going to say from 0 up to 3. So x must be bigger or equal to 0, smaller or equal to 3. It helps to sketch it, okay, sometimes you can clearly see where it's below the other one. Okay. Right, so another very important question that they can ask is they can take the two graphs and multiply them with each other and ask where is it smaller or equal to 0 or smaller than 0 or bigger than 0 or bigger or equal to 0. Or they can divide them with each other and ask where is it smaller than 0 or bigger than 0 or smaller or equal to 0 or so, okay? So these two questions are very similar, okay? And when they say gx, it's obviously y. Gx is y times y. So you look at the y values for g and the y values for f. And when you multiply them, you want to know, in this case, where is it smaller than 0, which means where will it be negative? Smaller than 0 means negative. So when is it negative? When one is positive and the other one negative. A positive times a negative gives you a negative answer. A positive divided by a negative gives you a negative. So the only time when you're going to get fx times gx or gx divided by fx or fx divided by gx, when you divide or multiply, when they're going to be smaller than 0 is when the one graph is positive while the other one is negative. So that's what you're looking for. That's all you're looking for. Okay. You look at the graph, you say where's the one positive and at the same time the other one is negative. If they said where's gx times fx bigger than 0, then you look at where are they both positive at the same time or where are they both negative at the same time. Because a negative times a negative is positive. Okay. So but now, smaller than 0, positive and negative. So if you look at, let's say we look here at 1. They're both negative. This one is negative, this one is negative. Because remember, you look at the y values. Okay? At x equal to 1, they're both negative. At x equal to 2, they're both negative. At, let's say, 4, they're both positive. At 3, they're both 0. It said smaller than 0. Now, when you go this way, at negative 1, 0, and this way is negative. Between negative 1 and 0, they're both negative. But now when I go past negative 1, back, okay? Now, let's say you're at negative 2. Now this one is positive and this one is negative. So from negative 1 backwards, the one graph is going to be positive and at the same time the other graph is negative. Which means the positive y value here multiplied by the negative y value here will give you a negative answer. So your answer is very simple. Your answer is just going to be x must be smaller than negative 1. That's it. Any value for x smaller than negative 1, you're going to have, you can do this in the test. You can do this. You can put in your signs positive, positive, positive. Yeah, they're both positive there. They're both positive. Here they're both negative. Those ones are negative. And now this one is negative. And now you just check anywhere. Okay, anywhere. 1. Negative for this one, negative for this one. Negative times negative is positive. So now once I go past negative 1 back, I'm going to get a positive times a negative. And then you'll give me a negative. So the answer is just x must be smaller than negative 1. Okay, if the question was, listen, if the question was, instead of this, if the question was where is it smaller or equal to 0? Okay, let's just focus on that. Smaller or equal to 0. Now you're going to be careful. Because now we're going to say x must be smaller or equal to negative 1. Okay, because at negative 1 it's a 0 times a negative, which is still 0. But now here at 3, it's going to be 0 times 0, which is also 0. So you're going to say or x equal to 3. So now there's two options. Smaller equal to negative 1 and then x equal to 3, because at 3 it's a 0 times a 0, which gives you 0. So if they put in the equal to 0 also, not just smaller than 0, smaller or equal to 0, you must look carefully, okay, to get the right answer.